Our Spring 2021 Chainlink Hackathon project, TrueSight, is a prototype for a new type of Oracle network built to provide moderation labels on user-generated content for decentralized applications. One of the major things that can make or break a social application is the quality of the content present on the site. Different platforms have different audiences, and moderating user-generated content on these sites is a difficult problem for even the largest of social platforms. Typically, this content moderation is done in a completely centralized way. Those running the site also employ the moderation service. Facebook, for example, currently employs around 15,000 content moderators. But this implementation lacks transparency and accountability, where no clear rationale may be given for why a piece of content is removed. Systems like these are vulnerable to influence from stakeholders, political entities, and large corporations. Decentralized applications offer users the benefit of censorship resistance, but this can be a double-edged sword in many cases, as content is either not moderated or the burden of moderating malicious content is placed in the hands of the users. It is important to consider a broad range of users' needs and how young or otherwise vulnerable users will be at greater risk of harm due to being presented with malicious content. Having the ability to determine the content of images, video or text before they are displayed to the user allows the application to improve the user experience. By making on-chain requests for an independent network of oracles to perform content moderation, applications are able to provide transparent and trust-minimized moderation to users. Our prototype includes a Chainlink node able to generate moderation labels for images hosted on IPFS using Amazon Rekognition, a cloud-based computer vision platform, via an external adapter. The back end of our TrueSight demo is shown in this simplified flow diagram. Firstly, a user uploads an image through the UI. This image is then pinned to IPFS by our back-end API using the Pinata SDK. The image content hash is then returned from IPFS to the web app, which then prompts the user to make a transaction in order to submit the content hash to the dApp smart contract. Upon receiving the transaction containing the image content hash, the dApp then requests image classification from a Chainlink node by passing the content hash to the node smart contract. This then emits an event on the blockchain containing the job details. An off-chain node listens for an event on its corresponding smart contract, which initiates the job run. The Chainlink node then executes the job, matching the job ID in the event, which includes calling out to our external adapter. The external adapter begins by requesting the image from IPFS, using the content hash originally provided. The image is then returned and passed by the external adapter to the image classification service, Amazon Rekognition. Amazon Rekognition then responds to this call by generating moderation labels for the provided image and passing them back to the external adapter. The labels are then pinned to IPFS, which generates a second content hash associated with them. The external adapter then returns the content hash converted to bytes 32 format to the node, which then completes the job by submitting the result back on chain to the node smart contract. The results are passed back to our dApp smart contract via the callback function specified in the original request. Here, the moderation labels are stored in a mapping against the image content hashes. Our demo web app can then transform the bytes32 string back to the IPFS content hash to fetch the moderation labels for each image. These are then presented to the user in the demo web app gallery, with moderated images being blurred with detected labels and confidence scores displayed over them. The user can now make informed decisions about the content they might be about to view. We hope you have enjoyed hearing about the ideas and research that inspired TrueSight, as well as learning about the mechanisms which power our demo. For more information about the project, please visit truesight.link, where we discuss implementation on a wider scale, as well as ways to further develop the idea. We want to thank Chainlink for giving us the opportunity to explore and develop this project as part of their Spring 2021 Hackathon. A short demonstration of our web app will now be given by Matt.
Hey everyone, so I'm just going to quickly run through this site we've built as part of our submission for the Chainlink Hackathon. So we've built this as a demo of a typical usage of the TrueSight content moderation network for generating moderation labels for user-generated content. It's kind of like an oversimplified social network app where users are able to upload images to a public-facing gallery. But before they're displayed to the public, the app requests moderation labels on these images from our prototype of the TrueSight network. So it can warn users of any potentially malicious content before they view the image. So I'm just going to go ahead and connect my MetaMask wallet here. And if I go over to the upload page and just select an image from my PC, there we have it. So I'm connected to the Mumbai test network here, and I've funded my account with some testnet Matic. So I can submit this transaction now to push the IPFS content hash onto our smart contract. If I check over on our contract explorer here, I can see that the contract call is successful. And if I go to our Chainlink node, I can see that the job run has been initiated here. You can see it's in progress. If I just dig into the details of that now, I can see there's our external adapter step here, this IPFS recognition step. And I can see the results from that are these moderation labels here. So I can see that it's flagged that there's a middle finger gesture in our image. If I switch over to Remix now and connect to our deployed contract, we can get all of the IPFS content hashes of all of the stored images here. And I can also get the moderation labels for each image using this mapping here. So the image moderation labels are returned in bytes 32 format rather than the standard IPFS content hash type. This is just to get around a current limitation that the maximum response size from a Chainlink node is 32 bytes. But we can convert this back to an IPFS content hash using a little function that you'll be able to find inside the repository. So I've just copied this into the URL of a IPFS gateway, so we should be able to hopefully see the moderation labels. It may take a while to load first time. In the meantime, I can also grab the content hash of the image so we can load that up as well. Excuse the monkey here. So it looks like our moderation labels have just finished loading, so we can see those have come through. So those are stored on IPFS. And the image seems to be taking a little bit longer. If we go back to our app, we should be able to see something. So yeah, the image hasn't quite yet loaded, but we can see that it's there with the moderation labels. So seeing as this image has moderation labels flagged against it, we should expect to see a blurred version of it before we click on it to view the full image. If the moderation label results indicated a lower confidence of something being flagged up, then instead of seeing this check mark, we'd see a percentage, as you can see on that image below as well. So it looks like the image is loaded now, so we can choose to view that if we want to. And that really concludes the demo. It's really up to the DApp, which is calling the moderation service, what it wants to do with the labels that are generated, whether it wants to just warn the user or flat out block images, either at the UI level or at the smart contract level. And taken further, the network could do moderation on other types of media as well, be it text or video. But I think the really key point here is that the moderation is being done in a completely transparent way by an impartial third party, so it can be completely separated from any kind of bias the operators of the app might be blamed for having, whether that comes from like a certain political stance or pressure from any advertisers or stakeholders. Thanks for watching.